Hello students, welcome back. I'd say Astro is a pretty much completed game. We can move our probe throughout space, avoiding asteroids, picking up fuel along the way, spending that fuel to accelerate and thrust in a given direction and move under drifting velocity and drag forces. In this video, we're going to build on that and add some final visual touches to our game. This game polish that we add will make our game look better, feel better, and kind of just be more fun to play overall. In particular, we're going to add 3 visual systems to our game. First, we're going to add a glowing effect to our thrusters. So anytime we fire our thrusters, we'll have a glow that sort of pulses behind the thruster, indicating that we are accelerating. Then we'll add a particle system that we'll use to eject from our probe. So our probe is going to shoot out particles anytime we accelerate, and we will move in the opposite direction. It's going to look really great when we're all done. And then finally, we'll create a warning overlay, something that sits over our game window anytime we get too close to the edge of our screen or we're about to run out of fuel. This will be like a visual flash that tells the player, hey, watch out, you're about to die. So let's head to the computer screen and let's dive right into these game polish systems. So I have lesson 8's starter file open here in vscode.dev. I'm going to minimize this file and also open that directly here in the browser. So I'm going to open my Astro folder, lesson 8, and lesson 8's starter file. So let's see what we have to start here. So all right, there's our start overlay. Deep space probe is ready. All right, so if I hit my thrust button, I get no glowing thrust, I get no particles, nothing there. What if I get near the edge of the screen? Is it going to tell me to, oh, there's no warning, and I am just dead. So I got no warning there. All right, so it seems like none of these visual systems are in place. Not a surprise, right? Because that's what we are going to do here in lesson 8, our lesson on game polish. So let's take a look. Mission number 1 says we need to adjust the polish constants. So we're bringing in some new systems. So we need to define some variables that we can use to tweak those systems. So we can change how they behave, how they change our game's visual look or gameplay. And that's going to be in our student edit zone. So you can see we've got some constants for like our stars and our player and our physics-based movement and our fuel and our ramp and our asteroids and our fuel pickups. And now, last but not least, we have some polish constants for our visual systems. So the first one is going to be for our warning margin. So if we look here, when do we want to start flashing a warning sign? So when we get to the edge of the screen, we're going to use a value that says anytime you get close enough to the edge, we'll alert the player and let them know, hey, watch out, you better turn around and get back into the main game area. Otherwise, you risk drifting off screen. That's not going to be good. So I'm going to set the warning margin here to be, I don't know, I'll just say 70. I'll pick that value. We'll test it out. So if we're like 70 pixels away from the edge here, we're going to start flashing, warning, warning, warning. I think that should be good. Now we're also going to have another warning. Another warning is going to be when our fuel is running low. So if our fuel is running low, we could potentially drift off and end up dying. So I'm going to say our low fuel warning threshold is going to be set to 20. So if we are at 20 fuel, watch out. We're going to give a warning. So that's going to be for our warning overlays. Now we're also going to do some things here for the particle system that we are going to create. All right, so anytime we apply our thrusters, we're going to shoot out particles at the back end of our ship. So how many particles per frame do we want to make? I'm going to make, I'll just do 2 particles per frame. And the particles spread, how far do I want them to vary in direction? So if I'm going to create the particles, let's just see. So right here, I don't want to just shoot them out in a straight line. I want them to sort of like spread out a bit. I'll set that spread to be 20. And then the particles are going to move at varying speeds. So I'm going to set a min speed and a max speed, and then we'll randomly pick from within that range. So my min speed is going to be 120, and that's my max speed. I'm sorry. My min speed will be 120, and my maximum speed will be 220. And then our particles are all going to have different lives, like amount of time that they are on the screen. So the smallest amount of time, their smallest life will be, I'll do 0.16. And their longest amount of time on the screen will be 0.30. I'll do that. All right, and then we're going to give them varying sizes as well. So I'm going to set a range for my sizes. I'll do 4 as the smallest and 8 as the largest. And so those are going to be the constants that we can tweak. And if we don't like how our particle system looks, we can always just come back here and change it later. All right, mission number 1, defining the constants for our game polish systems is all set. So now let's look at mission number 2. Mission number 2 says, hey, we should reset our polish variables on game start. So clear the particles and reset the warning state. All right, so this finds us in our reset game to defaults function where we've spent a lot of time, right? Anytime we introduce a new system, we always kind of reset it. So let's go see what gameplay variables we have for this system. So here are all of our gameplay variables right outside of the student edit zone. And so if I look, it seems like we have a particles array, so a container to hold every single particle that we create. So that's going to be great because it's going to allow us to loop over that array and do operations on every single particle. Then we've got, it looks like we have a variable called thrusters are firing, and it's set to false. All right, and so when we hit the spacebar to fire our thrusters, we're probably going to want to set that to true. So this is going to be a Boolean variable that keeps track of whether or not we are applying our thrusters, whether or not we're accelerating. And then we have another Boolean value, a true or false value, called player is in danger. It's set to false, and I bet that like if we get near the edge of the screen, we would say, all right, set player is in danger equal to true. So we're probably going to mess with that there. So what we want to do is we want to make sure we reset these at the start of our game. So at the start of our game, if there's a bunch of particles on the screen, I want to make sure I get rid of them. So let's take the particles array, not particles, particles. You got to spell it right, particles. And I'm going to make it an empty array. So we're going to empty it out. And then let's take those 2 Boolean values. Like if I was firing my thrusters when I died, I just like smashed right into an asteroid. I got to make sure that that value, which would have been true if I smashed into an asteroid, is set to false. So I'm going to say thrusters are firing, tab to autocomplete, and we'll set it equal to false here. And then there was one more variable in this system that we want to reset, and that is our player is in danger. We're going to set that to false as well. All right, so now every time we restart our game, these variables for our system, and right now would get reset. So perfect. So we are starting off in the correct state. Mission 1 is done. Mission 2 is done. We have defined the data that we need here. And so now we're going to begin to update the data here in mission number 3. Mission number 3 is all about our thruster glow. So we're going to trigger the thruster glow effect while our thrusters are firing. So this finds us in our update thrusters function, which we run every single frame. And if our thrust key is down and we have the fuel, we apply our acceleration to our velocity and we use up some of our fuel. But now what we want to do is we want to inform our computer, our program, that, hey, we are in fact applying the thrusters. So we're going to do 2 things here. We're going to create a glowing effect that is going to pulse around the thruster. So right here, that orange glow should start glowing and pulsing. And I want to spit out particles. So I want to do 2 things anytime I am providing some thrust. So the first thing that we'll do is we're going to update the thrusters are firing variable, and I'll set it to true, because I'm firing my thrusters. And then I want to create some particles, right? It says spawn some particles. Well, let's go see what we got. So we're introducing a new system. Let's go see what functions are available to us in regards to particles. So if we look, when we introduced our asteroids, we had generate asteroid data, spawn asteroids, update asteroids. When we introduced our fuel pickups, we had generate fuel pickup data, spawn fuel pickup, update fuel pickups. And now we're introducing our particles. So we have generate particle data, all right, spawn particles, and update particles. Hey, this is pretty good. We've seen this sort of structure before. Anytime we implement a brand new system of objects that we are going to put into our game world, we have 3 functions that go along with them: generating the data, spawning the data, updating the data. So if we look here in spawn particles, it says for let I equal 0, I less than thrust particles per frame, I plus plus. So what did we say? Thrust particles per frame is 2 right now. So this is going to run twice. We're taking our array of particles, which is empty, and we're pushing into it whatever is returned from the generate particle data. So we've seen this structure before. And if I go to generate particle data, it looks like That's one of our missions. So we're going to have to write that data structure. But for right now, I just want to make sure in mission number 3 that when I fire my thrusters, not only am I setting my Boolean thrusters are firing to true, but I'm also going to spawn some particles. So I'm going to say spawn particles. We're going to call that function. And now we've done both. We're going to activate the glow. That's this right here, thrusters are firing, and we're going to spawn some particles. So it looks like mission number 3 is done. Let's move on to, well, let's see, is anything going to happen yet? I doubt anything happens yet. No, we get no visual effect. I mean, I'm hitting the spacebar to thrust. The value of that variable is changing to true, but we're not drawing anything yet. So I think the next step is probably to draw some change in regards to our thrusters that are being fired. So let's look at mission number 4. All right, mission number 4 puts us in the draw player function. So we draw the player's body, we draw the player's accent, we draw the player's thrusters. All right, so not too bad, but now this is new. We're asking a question. We're saying, hey, if thrusters are firing. That's that Boolean value that we just set to true anytime we press the space bar. And so if the thrusters are firing, that question is yes. Everything that we have in here inside of our code is going to run. And so let's look at what we're doing. So we're creating a constant variable called pulse. And ooh, this is interesting. Pulse is equal to a sine function, the sine wave. Now, we've talked a little bit maybe about sine and cosine and how they apply to like triangles, but we can also look at sine as a wave form. And I want to draw really important attention to. Sine takes in some value inside of here. So it looks like we're taking runtime seconds and we're multiplying it by 20. So however much time is run by 20. And then we're multiplying that whole sine function by 3. And then we're adding 8 to it. And we'll talk about all of this here in a moment. So we're getting this thing called pulse. All right. And then we're putting some paint in our paint bucket called player thruster glow. Why don't we draw, so it looks like we got some paint in our paint bucket. Let's draw a new circle. Let's just see. Let's draw a new circle. So we'll do circle. And I'm going to put it at, I want this glow to be around the thruster, right? So wherever the thruster is positioned, I want to make the glow right around that. So let's, oh, look here. When we drew the thrusters, we defined thruster X and thruster Y. Remember, we did it based on the player's NX and NY position. Those are the directions to the mouse that we set up. So let's use those as the circles X and Y centered. So thruster X and thruster Y. And then we need a size. I don't know. What was our thrusters? It was just player radius times a half. Let's just do player radius. Let's see what happens. Player radius. So this should be bigger. What is the player thruster glow color? All right, so if you look here, that color is an RGB alpha string. So 255, 179. So it's going to be like that orange color. I think that's like the same color as our thruster. But look at the alpha channel. The transparency is 0.35. So we're going to be able to see behind it. If I refresh the page, what do we get? So when I thrust, I don't really see anything yet. Okay, so that's not yet working. So we got to do a little bit more here. Okay, I want to apologize. I just had to pause the video because for some reason my program wasn't saving and I wasn't seeing the this glowing effect when I knew I should have. And so I figured out my save issue. So now it is saved. There, if you ever see a little dot up here in the corner of your program, it means it has not yet saved and you have to manually save it. So just be aware of that. So now that I'm drawing this circle, let's go look at what we are going to get when we apply our thrusters. So right now if I apply my thrusters, all right, there's our circle. It sort of looks all right, but I think that's not really the effect I want. So why don't we take that radius and let's make it bigger. Let's do like times like, I don't know, 6. Let's just make it much, much bigger so we can see it a little bit better. Whoa, that's actually sort of cool. Not what I want at all, but kind of cool. I don't know. Let's make it like times 2. Let's just do, well, let's do like times 3. So what we want to do is we want to make it so that this effect is big and then gets smaller and then gets smaller and smaller and smaller and then bigger and bigger and bigger. I want it to grow and shrink so that it looks like it is pulsing. So we got to figure out how we go about doing that. Well, the trick is using this pulse variable right here. So what we're going to do is we're just going to take that player radius, and instead of by multiplying it by something, I'm going to add something to it, right? I could take this and add, oh, I don't know, let's add like 50 to it. So if I do that, you can see that's big. And so now I'm going to add a smaller number, 20. All right, so if I do that, now it's smaller. And let's add 5 to it. So if I do that, it's even smaller. And so we're going to add a number that's going to grow and get bigger. So like 5, 10, 15, and then shrink 10, 5, I don't know what it is. But and that variable is going to be pulse. So let's see it in action, and then we'll discuss how we get it. All right, so let's see it in action. So if I now add that pulse variable, we can see my little thruster is pulsing. That's kind of cool. It's got a nice effect. Now, if you want to mess with that effect, there's two values we can change. We could change this first number right in here inside of the sine function. That's known as a relationship called the frequency. So I can make it bigger and it will pulse faster. So I don't know, let's make it like 40. All right, so now if I refresh the page, it's going to pulse faster. So you can see it's faster there. So maybe you like that. And if you want a bigger pulse, you can change this number. So this is known as the amplitude. So instead of making it 3, if I want it to be bigger, I'll make it like 6. I'm going to double it. So let's take a look. And so now you can see that that pulsing effect is bigger. If you really want to see it, let's make it 16. All right, so now it is getting even bigger. Now, what is this 8? That adding 8 just represents a baseline. So the pulse, we're always adding at least 8 to the pulse. Without this, we could get a pulse of 0, but with 8 here, it guarantees that our minimum value is going to be 8. I'm going to go back and set this to 3 and 20 because I like those numbers. And what I want to do really quick here is just go to my whiteboard and highlight what exactly is a sine function. What is a sine wave? So a wave here can be thought of as just something that repeats itself at regular intervals. So it goes up and it goes down. All right, so there's one wave, and then it repeats itself at regular intervals. It goes up and it goes down. All right, and so if we think about it, this might be like, oh, I don't know. Let's just say this is +3, and this all the way down here is -3. So our wave can make our pulse get bigger, 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 and then smaller and smaller and smaller, and then bigger and bigger and bigger in the negative direction, and then smaller and smaller and smaller, and bigger and bigger and bigger, and smaller and smaller. And different waves have different heights they can go to. So maybe I could draw another wave that goes much higher, and much lower, and much higher, and much lower. And maybe this is a wave that goes up to, say, +6, and all the way down here to -6. This distance is represented by something called the amplitude of the wave. And so we mess with that. That was like the 3, we changed it to a 6, all that good stuff. Now, there's also something called the frequency of the wave. So the frequency of the wave is basically how many waves you can fit into a given region. So imagine I had this region of space or time, and I could fit in, oh, I don't know, let's just say I fit in 1 wave, 2 waves. All right, so that is related to the frequency. Now imagine if I had another wave where I could fit a lot more. So there's 2 waves, 3 waves, 4 waves. That's double the frequency. So you can see the oscillations are happening much faster. And that's exactly what you saw when we messed with our 20. So that is our frequency. So we can mess with the frequency or the amplitude right here. All right, so our thrusters, I think I like that effect. Let's just refresh the page, make sure I like that final version. Yeah, I like that. That slow pulsing effect looks good. And I think it's going to look even better once we create some particles. So now we are on to mission number 5, because our thrusters don't just need to glow. That's the glow of the engine. Now we have to emit something out into space. And what we are going to be emitting is particles. So mission number 5 says define and spawn our particles. And this puts us in our generate particle data function. We already sort of looked at this, right? We said, hey, we're introducing new objects into our game world. So we are going to generate the data, spawn the data, and update the data. If we look here, we have some variables that we are going to set: thruster X, thruster Y, speed, life, and size. And then we're returning an object that's going to represent a particle. So it looks like our object is pretty much set. I mean, the X value of the particle is going to be our thruster's X position. The Y value is the thruster's Y position. So that looks pretty good. Of course, the thruster's Y position is currently set to 0 here, so that doesn't seem right. I think we got to get that thruster's Y position. We've done this before. I mean, we did it way down in our like draw function, but we can do it here because we have the X position of our thruster correct. So we're going to get our player's Y position, so the Y property, plus the direction that the mouse is in relation to that player, and that's stored in the NY property, and then we'll multiply by our player radius. So we're just mimicking that line up above. All right, and so then we have the player's speed, the particle's speed in the X direction and the Y direction. So we're taking into account the direction of the thruster, and we're multiplying by the speed variable plus some spread. Remember we said our particles are going to go out in different directions, so we're adding our spread here as a random number from -20 up to 20. So we got to actually adjust the speed here because I don't want the speed to be 0. I think we set some constants that we were going to randomly pick from a range, right? So we're going to do random, and I think the constants were thrust, particle speed. Oh, not max, min. There we go. Thrust, particle speed, min, and we're going to go up to thrust, particle speed, max. All right, so that looks good. We got to set the life of the particle. Well, I think we set constants for the life, right? We had a minimum life and a maximum life. This is the time that they were going to be alive for. So we'll randomly select thrust underscore particle underscore life min, and then we'll do thrust particle underscore particle, spell it right, particle life max. All right, so now our life is set. But then we got one more that we have to do, and that is for our size. The size shouldn't be 0. We have constants that we can randomly choose from for this. So we're going to do random thrust underscore particle size min and thrust underscore particle size max. Hey, I believe now that we have those constants defined correctly, we did that perfect. So our position's correct, our velocity, our size, and our lifetime are all set. And we are setting them here in our object. We are good to go with our particle system with mission number 5. Let's see what mission 6 wants us to do. Well, let's just see. If I run this game now, what's going to happen if I spawn particles? Ooh! I'm sort of getting particles. They look like cheese balls. That's pretty cool. I mean, I'm not going to lie. This effect is actually really kind of cool. They're not moving correctly. You definitely can tell that they are just moving horizontally, right? When I shoot them out, their movement is just in the X direction. They don't move in the Y direction at all. I move in the Y direction, but the particles aren't moving. But this looks really cool. It's almost like we're creating our own little galaxy, but a galaxy of cheese balls. But we got to fix this. So if we go to mission number 6, it puts us in the update particle function. So every frame, we're going to update our particles. If you notice here, we're looping through our array of particles, and we're doing it starting at the end of our array and going backwards. That is a clear indication that it's probably because we're going to be getting rid of particles. And we are going to get rid of particles once their time runs out. So if you look here, we select a particle from the given array. So we work with just particle now. And I'm going to update that particle's X property by looking at their X velocity and multiplying by our time interval, dt. So we've seen that relationship before, and it's working in the X direction. We just got to finish it for the Y direction. So particle dot y, we'll update their Y property by taking their Y velocity, particle dot vy, and multiplying by dt. So repeated patterns is the name of the game here with our particle system. So now if we launch, let's see, they should move not just horizontally, but also vertically. Hey, there they go. And we just shoot those particles into space. And I don't know about you, but I think we set the life of those particles to be like half a second, and they just keep going. They don't ever die. So we gotta figure out why that's not working. Although it looks pretty darn cool, but we're gonna remove the particles, and the reason why is because we moved the particles, but we're not fading them out over time. So there's still something else that we need to do. We have dt, right? We have access to our time interval, and our particles have a life. That life is randomly selected from 0.16 seconds up to 0 0.3 seconds. And so what we're going to do is every time we run update particles, not only are we going to move them, but we're going to take that life property, so particle.life, and we are going to subtract dt. And if that life gets to be less than or equal to 0, what do? Then we remove it from the array. So now we have our actual life in place. And so you can see our particle stream does not shoot out as far. All right, so that looks much more realistic for a thrusters. Now, if you want a bigger stream of particles, what could you do? You just go up to the student edit zone, and we can come right down here to particle life, and let's change 0.3 to, I don't know, be 0.8. And so now let's see what happens. So I get a larger stream? Yeah, so there's that larger stream if that's more your fancy, if that's what you like. So I'm going to set it back. I liked my 0.3. I'm going to keep it right there. But mission 6 is in the books. Let's look at mission number 7 now. We're coming up to the end. Ooh, this is our third and final visual system here of our danger detection. We want to detect when the player is near the edge of the screen or low on fuel. So right now it just says player is in danger, and it is equal to false. Well, remember we had that variable, right? One of our gameplay variables. Let's go to our gameplay variables. Was player in danger, and it just says false. Well, we don't want to just set it to false. We got to ask like a question, I think. We want to determine whether or not it should be true or false. And this function, let's see, is getting called every frame of our game. We're in our draw function that runs every single frame. And if we're in the play mode, we update our ramp, update our thruster direction, update thrusters, update drift, asteroids, fuel pickups, particles. So we're updating our particles. That's great. We're checking for asteroid collisions, fuel pickup collisions, and now we're updating our danger warning status. And that's where mission 7 puts us. So this is going to get called every single frame of the game. But I don't want to just assume the player is not in danger or assume the player is in danger. So instead, we're going to write a sequence of questions here. So my sequence of questions, I'm going to do it on multiple lines. I'm actually going to get rid of that, and I'm just going to tab in here. So the first thing that we're going to check is we're going to remind ourselves that we have a variable called warning margin, okay, which I think we set to like 70 pixels. So if the player's X position gets less than the warning margin, so here's my X warning margin. If my player's position is less than that, I'm like going to go off the screen on the left side. So that could be a bad thing. So we're going to say, hey, player.x less than warning margin. So if that happens, then if the answer to that question is yes, then player is in danger is going to be true, right? If this question is yes, is the player's X value less than our warning margin, then we're going to go off the screen on the left. That is true. So a player is in danger. It gets set to true. But that's not the only way they could be in danger. So we're going to say or. So we're going to ask or. Now let's look at them going off the right side of the screen. So going off the right side of the screen, the player's X position would be greater than, well, maybe like here's the width, and we're going to subtract the danger margin. So if the player's X position is greater than the width minus that danger margin, then we got to warn them. So this is going to be player.x greater than our width minus our warning margin. But that's not the only way we could go off the screen. We could go off the screen at the top. So at the top here, if we look, I better move. Oh, I didn't move in time. We don't want to, let's see, once we get, right to the HUD, this is where the danger is going to start to happen. So we're going to do our HUD height, and then we're going to add the warning margin. So if we're like here, then we're going to display, you're about to drift off the screen. So this time we're going to target our players.y and see if it is less than the HUD height plus or minus our warning margin. No, plus our warning margin. Yeah, I was right. Plus, we got to move down. We got to move down the screen, right? Plus our warning margin. But we also have the bottom we could go off. So for the bottom, let's see if we can figure this out without going to the screen. Our player's Y property could be greater than the height of the game, the height of the canvas, but then we want to subtract the warning margin to go back up. So we're adding all of those. So if this is true, or this is true, or this question is true, or this question is true, we are in danger. And then there's one last way we could be in danger, and that is if our fuel is less than or equal to our low fuel warning threshold, which I think I set to 20. Yeah, 20. So if any of those things are true, we are in danger, and we are going to alert the player. Mission 7 is done. And so now the last question is, how do we go about alerting the player? Well, we are going to call an overlay in our draw scene function. So in our draw scene function, we already have a couple of overlays. We have our draw start overlay being drawn if a condition is met, our draw lose overlay drawn if a condition is met. What other overlays do we have to work with? So let's scroll down. We got draw background, draw particles, draw asteroids, draw fuel pickups, draw player, draw danger warning. I think that might be our overlay that we are going to be working with. So we got draw danger warning. I think that sounds great. So if we look here, it looks like we're drawing a warning color, a border. We're saying no fill, so we're putting no paint in our paint bucket, and then we're loading up our marker with stroke. Instead of having an invisible marker, we're putting a colored marker that looks like it's red, and then we're setting the stroke weight, which means the thickness of the marker, to be 8. So we're going to get a really thick red marker, and we're going to draw a rectangle around our window. Now this line right here is going to make our rectangle flash on the screen, and it's going to look really, really cool. So we just got to make sure we call the draw danger warning function at the correct time. So let's go up here and let's say, all right, if, so this is like one of our overlays, if some question is true, then we are going to call draw danger warning. All right, so what is the question? Well, we have a variable that's keeping track of the state if we are in danger, and that is player is in danger. It's the variable that we had just previously set. If that variable is true, we're going to draw our danger warning. If that variable is false, we won't draw the danger warning. So let's check it out. I think this is going to end our game. Let's see. Let's see Astro Drift in its entirety. So here we are. I'm just a little probe hanging out. All right, I'm going to explore. I get this nice glow effect. I get some cool particles. I'm going to drift near the, I'm going to try to pick up this fuel pickup. All right, I got it. Oh, I'm getting too close to the edge. I get a warning. I leave, and the warning goes away. Hey, that's pretty good. Let's see if I use too much fuel. If I use too much fuel, what's going to happen? All right, my fuel gets down to 20. I'm actually doing a really good. Oh, goodness, I thought I was doing good. Okay, so we got to be getting close. Oh, I think it flashed right there before you could see it. So let's just see. What if I just spin in a circle and get rid of my fuel? I'm pretty sure we were flashing there because of my low fuel warning. Let's just check it out. I just have to not die before we get there. All right, so we're coming up. Okay, so there I'm certainly at my low fuel warning. If I pick up this fuel, is it going to go away? All right, and then that overlay goes away. And of course, if I get too close to my edge, boom, we have the warning, we have the visual feedback, we have a completed game. I'm super proud of how this came out. This was a great culminating lesson that added some visual systems to our game, a little bit more flair. It didn't necessarily affect our gameplay, it just made the gameplay experience that much more enjoyable, adding the glow of the thrusters, our particle systems, and our warning overlays to give visual feedback. So I think this is a great place to stop, and I'll see you in our next video.